Hi everyone, today's tutorial shows how to use Composable Camera System to create an isometric top-down camera. This method also works for other fixed rotation views, such as side view. First, use ccs.debug.panel1 to open debug panel, making later checks easier. Now let's look at target result. As you can see, camera rotation stays fixed. Camera only follows character movement. Next, let's see how to build this effect. In this demo scene, I use TriggerBox for testing. So next, we still use TriggerBox to trigger camera switch. Duplicate it, select this trigger box, then define enter and exit events in level blueprint. Call active add a camera in both enter and exit events. On enter, call isometric camera we are about to create. On exit, switch back to current third-person camera. Select transition asset. I use default smooth transition with 2-second duration. Context uses gameplay. Next, find Asset folder. Right-click and create camera asset. Name it whatever you want. Now, we need to add nodes to this asset. Before that, let's clarify exact target behavior. Camera must not rotate, so we do not add rotation-related nodes. Target rotation comes from initialization. Camera follows target movement, avoids vertical bobbing, and keeps certain distance. So this camera asset mainly handles follow movement logic. This is basic function for most cameras. 1. We need to know which character to follow. Add receive pivot actor node. It gets pivot position from an actor. Set pivot actor source to control pawn, meaning pivot actor is controlled character. 2. Add pivot offset node. It applies offset based on previous position. Here we do not actually need it, but other cases may need it, so we add it here. 3. Add pivot damping node. It smooths pivot movement. Most cameras need this node. It makes camera movement smoother and reduces motion sickness. Four. Add camera offset node. This is most important node. It defines relationship between camera and pivot. Here we enter random values first and check result. 5. Finally, add field off view node and set FOV. Back to level blueprint, set camera asset we just created, then set activation params. Most important part here is in a shield transform, meaning desired rotation for this isometric camera. I use random pitch and yaw here. Also remember to enable use initial transform rotation. Back to level. Check result. Rotation now matches configured value, but camera offset is wrong. Need more adjustment. Next part plays debugging process at 3x speed. Final setup. Pitch equals 50, L 45. Camera offset equals 5,100,000. Result looks good. We can also try larger pitch, -70. Now adjust values in pivot damping. Increase leftward and rightward damp time. Now camera follows more slowly in left-right direction, while other directions stay unchanged. That's all for today. Next episode, we will build simple lock-on camera.